Welcome back to Rock the JVM. I'm Daniel, and in this video I'm going to talk Apache Spark, and in particular I'm going to talk Apache Spark joins. This video will assume that you are a beginner with Apache Spark. So this is a entry-level video for Apache Spark. And as a nice to have, it's really good if you have some SQL experience, because we're going to illustrate some of the analogies between Spark and normal databases, but it's not mandatory experience. As always, I'll recommend that you code with me in this video, and whenever you need to refresh your memory on these topics, refer to this video or to its written form at the blog with the link in the description below. Now for this video, I'm going to use an IntelliJ project, so I'm going to write some Scala code in a dedicated Scala application, and if you want to do the same with me, you will need to add the following lines to build.sbt. So you'll need to add the Apache Spark dependencies so that you can use Apache Spark as a library in your Scala application. So you'll need to add org Apache Spark, Spark core, and then Spark version, and org Apache Spark Spark SQL % Spark version, where Spark version is 3.0.1, which is the latest at the moment of this recording. Alternatively, you can download a dedicated Spark installation to your computer. So you can go to Spark Apache org and then click this bright download tab over here, and then you can download a dedicated pre-built, pre-compiled Spark installation on your computer. You will need to navigate to the bin folder, and then you will need to execute Spark Shell, which already has the boilerplate set up for you. Now, if you go this route, just execute Spark Shell and then write the subsequent code with me. Alternatively, if you choose the Scala route, you will need to add a Spark session builder just so that you can have access to the Spark APIs. And for this, you will need to first, let's set up a main just in case we need to test something. And then I'm going to define a Spark session that I'm going to call Spark. So Spark session builder. And then I'm going to give this an app name. I'm going to name this all the joins. And then I'm going to set master to local, and then get or create. Okay, so this is the Spark session that the Spark Shell will automatically have once you start it. So if you go down the Spark Shell route, you'll also have this Spark session already built for you. You don't have to write this code. And you'll also have the Spark context, which is almost always named SC in practice, and I'm going to use spark.spark context. Cool, so you have the boilerplate set up. Now this video will explore the different kinds of joins supported by Apache Spark, and here we will use the DataFrame API, but the same concepts are also applicable to the low-level RDDs as well. Cool, so let's say we're working on a data set of kids where they need to be organized into teams to complete a project for their school. And to just assume lots of records in practice, like millions, billions of records, but just to make the computational tasks here easy for the computer, we are going to work on smaller data, just to prove the mechanics of joins. Now, you can copy the code that I have on the blog, so I've navigated here to the article. You can check it in the description of this video, and you can scroll down and then you can simply copy this particular code. So I'm going to copy these data frames where I have a small set of kids that I've defined, and I'm also going to copy the imports that I'm going to place at the top of the file. So after the imports, the code should look clean again, and let's go through what we do here below. So we simply have a kids RDD, which is sc.parallelize, and I'm parallelizing a list of plain rows, and each kid has an identifier, 40, 41 to 46, so we have 7 kids here. Each kid has an identifier, a name, and a team identifier that they are part of. Okay, so the kid with identifier 40 is called Mary, and she is part of team number 1. Okay, so this is what every single row of this data means. Now, I'm turning this kids RDD into a data frame, so I'm going to work with a kids DF over here, and I'm going to use this kids schema to create the data frame. And I also do a very similar thing with teams. So I'm going to create a parallelized list of teams where every team has a name and an identifier. So we have team number 1 is called the Invincibles, and so on and so forth. And I'm also going to define a data frame of teams, which I might have forgot to copy from the blog, but I'm just going to copy this line over here, and I'm going to call this teams.df. And I'm going to pass in teams and then teams schema. Okay, so a very similar thing with teams here in another data frame. Cool. So at this point, I'm going to show you various ways of figuring out which person gets into which team. So for every single kid, we want to know the names of the teams, for example. And for that, we will need to join these two data frames. You might have heard about the concept, and I'm going to show you various join types in Spark. Now, before you close this video for being too simple, if you've heard about these concepts before, I'm also going to show you some joins that you may not have heard before. Okay, so Spark supports some joins that are not available in standard SQL, and I'm going to show you what they are in a couple of minutes. So let's start with the very basics. We are going to start with inner joins. So inner joins are the most natural kind of joins. If you wanted to know the team names for every kid in this data set, we would do something like let's call this join condition. So you would write something like a join condition that you would pass to a join call. So I'm going to say kids data frame dot column, let's call this team, must equal, and I'm going to use the triple equal sign because we are working with column objects and they have their own API for that, so do not mistake it for the Scala double equals. I'm going to say teams.df dot column ID or team ID. And if you wanted to insert this join condition into a join call, I'm going to say kids teams data frame as kids.df dot join with a teams.df under the join condition. And you can leave the third argument blank, or you can optionally add it here as inner, because the third argument has the value inner by default. That is because the inner join is the most natural kind of join. An inner join will only contain the rows from the first data frame, we call this the left data frame, combined with every single row from the other data frame, we call this the right data frame, such that the join condition holds true for those rows. So for example, if Mary is in the team 1, the only row that matches the condition that the team 1 must equal the team identifier 1 here is the combination of this row with Mary with this row with the Invincibles. And the two rows will be combined into a complex row. So we are only going to see for every single kid which teams they belong to, provided that they belong in a team. And so if you wanted to say kids teams df.show, you would see a table with all the kids and all the teams that they belong to, if they belong to any team at all. So let's give Spark a couple of seconds to actually run this, and notice that every single kid except one has a team name. So Mary and Charlie are the Invincibles, Jane and David are rock stars, and Angela and Jimmy are dog lovers. Good. So this is called an inner join. There are various other kinds of joins, which I'm going to show you shortly, and I'm going to show you outer joins. Now, assuming we still want to attach a team to every kid, this inner join will completely omit the lonely kid in the data frame. So if you spotted the difference between the first data frame and what we saw in the table a couple of seconds ago, you noticed that the output here contained only 6 rows, whereas the original data frame contained 7 rows. That is because the kid that we named here Lonely does not belong to any team at all. This poor kid doesn't have a team. We would like to be able to show this kid in the resulting table by placing a null next to it. So a null value next to this kid so that the class teacher can spot poor Lonely and assign them to a team. So for this case, we will do a left outer join. So all the rows in the first, that is the left data frame, will be shown. So not just those for which there is a matching row on the other data frame. So all of them will be shown with the corresponding rows from the other data frame combined for Mary, Jane, David, Angela, Charlie, and Jimmy, for example. And if a row doesn't have a matching row on the right data frame, we will have nulls on the corresponding columns. And for that, we will show, for example, let's call this all kids teams df as kids df join with teams df under the same join condition. And we are going to use left underscore outer. So left outer means that all the rows in the left table are kept and nulls for the rows that do not have corresponding values there. So I've actually gone ahead of myself before calling show. So I'm going to say all kids teams df.show. I'm going to remove this first one. A couple of seconds for Spark to do its thing, and we will see 7 rows in the corresponding data frame. So notice that the poor lonely has nulls where the team ID and the team name should be shown. The other kids are the same as before. There's also the concept of a right outer join. In the case that there is a team with no members, we will keep all the rows from the other data frame and nulls from the corresponding table in the first data frame. So I'm going to, for example, let's copy this line. I'm going to say all teams kids df, and I'm going to use right outer, and I'm going to call show on that. So I'm going to say all teams kids df show. And in this case, we will see all the teams plus the team that has no members, because we have a row here, the non-existent team, which doesn't have a kid in this team. So notice that we have the Invincibles, Rock Stars, and Dog Lovers each having their own members, plus the non-existent team, which has nulls on the left-hand side here. Okay, so this non-existent team doesn't have any members. So we have left outer and right outer. There's also the concept of a full outer join by combining these two results. So I'm going to say all teams kids, let's call this full teams kids df, and I'm going to show this one where the join condition is full outer. So I'm going to use the full outer join, and if I run this application again, we will see a very interesting table. So a couple of seconds. Let's crunch the data, and let's see what Spark actually does. So notice that we have the same table as before, so the Invincibles, Rock Stars, and Dog Lovers, plus the 2 weird rows in our data. So we have lonely with no team, plus the non-existent team with no members. So both rows with non-matching keys are also shown here. So this is outer joins. Now, inner joins and outer joins, both left, right, and full, are some of the first joins that you learn when you study Apache Spark. You might have heard of these concepts before from regular SQL. So these I'm expecting that most Spark programmers have actually dealt with. However, this is where the fun starts, because I'm going to show you some very different joins in Apache Spark that are not available in regular SQL. And I'm going to show you first semi-joins. This might be a new concept. So semi-joins are something else. Semi-joins take all the rows in the left table in the first data frame, such that there is a row in the other table with where the join condition holds true. In other words, the semi-join is a kind of a filter. So let's take all kids with teams as kids df dot join with teams df with the same join condition, and I'm going to use left underscore semi this time around. This particular expression will return all the kids which have teams, but not necessarily we care about the team names. So I'm going to say all kids with teams df dot show. And I'm going to remove the first show, and I'm going to run the application again. A few seconds. And notice that we have all the rows from the first table except lonely, because lonely doesn't have a team. So we have only 6 rows in the first table without additional columns. So this acts like a filter. Now in SQL terms, this will be a select star from the first table, from the left table, where, and then you have exists. If you've done enough SQL, you know that there is an exists clause, and then you can have a subquery here, select star from the right table, where, and then you can insert your join condition here. But this particular structure over here is very hard to express in Spark, which is why Spark has this left semi-join as a standalone concept. Okay, so this is a semi-join. Now, I'm also going to show you a new concept, which is an anti-join. So anti-joins are also very interesting. They're essentially the opposite of a semi-join. They return all the rows from the left table such that there is no corresponding row on the right table. So in our case, if you wanted to show all the kids which do not have a team, you would use an anti-join, and this will show only lonely. So I'm going to, let's say, let's call this kids with no teams df as kids df join with teams df under the same join condition, and I'm going to use left anti, and I'm going to say kids with no teams df show, and in this case we are expecting only lonely to show up. A couple of seconds to run, and while Spark does its thing, the equivalent of this anti-join is a SQL statement where you have a not exists. Okay, so this is also a kind of a filter where the subquery doesn't return any results. So notice that in this case we only have lonely, which does not have any corresponding teams. Now, the final join type that I'm going to show you is a cross join. So cross join will do a Cartesian product between two data frames, so all the possible combinations between a kid and a team, regardless of your join condition. So I'm going to say, let's call this product kids with teams as kidsdf dot cross join with teamsdf. And notice that this API does not take additional argument. The join condition doesn't really matter. So if I do product kids with teams dot show, then this will return all the possible combinations from kids to teams. And we have 7 kids and 4 teams, so we're expecting 28 rows in our data. But Spark will only show the top 20, and notice that this table is pretty big and we have all the possible combinations. Mary going to every team, Jane going to every team, David going to every team, and so on and so forth. Now be wary of this cross join at the very end here, because if you have big-ish data, the size of the resulting data frame is gigantic. So this is the product of the sizes of the individual data frames that you want to join. So even for small data, for medium data, this can really blow up. So make sure you really know what you're doing before attempting a cross join with production data. All right, so this is a quick overview of all the join types supported in Apache Spark. All right, so I hope this video was useful, especially if you're a beginner with Apache Spark, and even if you're a little bit more experienced, I hope you still got a lot of value out of it. Don't forget to click the like button for me and subscribe if you like this video, and follow us on Twitter and LinkedIn for fresh updates on upcoming material. As always, I'm dying for feedback, so please leave your comments. I read every single one, and check out the Rock the JVM website. We have tons of content like this, including full-fledged training with Apache Spark. Until next time, I'm Daniel, signing off.